Hello students, welcome back to my channel Maths Made Easy with AB. Today in this video we will be learning about periodic functions. So we will be covering entire periodic function in this video itself, and I hope there will be no second part for this video. So let us understand what we have studied till now. We have seen functions as a whole. We have seen functions as a whole, basics of functions we have done. We have understood how to find domain of function. We have seen how to find range of function. So basically till now we have already created, we have seen odd and even functions and all these in that. So 10 videos have been covered till now. In the 10 videos, these topics and some topics on functions like what is odd and even function, how do you find it, how to draw a graph of those functions, etc. have been shown in that video. If you have not seen those videos, it will be my request, if you are a serious candidate preparing for JEE mains and advanced, do go through those videos and then you can come back to periodic function. Even if you are in periodic functions for the first time, I don't think you will face any difficulty since we will be solving this from scratch. So now let's get started directly to understand what are periodic functions. So students, understand, basically you know a function is defined by y is equal to fx in a domain, on a domain D, is said to be periodic. A function y is equal to fx, a function y is equal to fx is said to be periodic in its domain D if for a positive number t, if for a positive, this is the domain, if for a positive number t, f of x plus t is equal to fx. Then the minimum value of t, the minimum value of t is known as the period of the function y is equal to fx. The minimum, the least positive value of t. So you have to understand t minimum means the least positive value of t is known as the period of the fundamental period of the function y is equal to fx. Clear, students? So if somebody is taking the notes, I'll just repeat for them. A function y is equal to fx, so you can see over here, a function y is equal to fx, right, on domain D is said to be periodic if there exists a positive number t, yeah, such that f of x plus t is equal to fx. Yeah, the least positive value of t is known as the fundamental period of the function y is equal to fx. So this is the definition of the periodic function. So this is the definition, and you need to understand what the definition is before you directly jump into solving numericals or finding the functions, finding the period of the function. So how do you solve the periodic function? It's very simple. How do you solve the periodic function? Basically you have to put f of x plus t is equal to fx. Simple. You have to put f of x plus t is equal to fx. So in order to find the periodicity of a function, you have to put f of x plus t is equal to fx and find, and what you will have to find, all the values of t that are independent of x, which means the value of t should not depend on value of x. So when we take an example, you will understand. Now for writing sake, these are few important points that you need to note it down in your notebook while you are studying with me. So you will have to do what? In order to find the period t, and students, I am teaching from very basics. So if you know nothing, then also you will be able to solve this problem. It's as simple as that, right? So what you will have to do, t, f of x plus t is equal to fx. So t is independent of x, students. T is independent of x. So basically you have to find all the possible values of t that is independent of x. If no positive value of t independent of x is possible, if no positive value of t independent of x is possible, if you are not getting any value that is independent of x, then remember that the function fx is said to be non-periodic. If you are not getting this, if you are not getting any value of any positive value of t independent of x, means if you are getting t dependent on x or something of that sort, or you are not getting anything, then fx is said to be what? Non-periodic, and at times it is also known as aperiodic. Non-periodic or aperiodic. So if somebody gives you it is a aperiodic function, don't get confused. So non-periodic means aperiodic. So basically there will be no value of t that will be independent of x, no positive value of t that will be independent of x. Yeah. So if positive value of t independent of x is possible, if positive value of, so I am writing it down, if positive value of t independent of x, again I am writing independent of x, is possible. If positive value of t independent of x is possible, then only fx is said to be periodic. Then only fx is said to be periodic. Then only y is equal to fx is periodic. Yeah, and what is the period? The least positive value of t. What is the period? The period is the least positive value of t. That's the theory part. The least positive value of t is the period of function y is equal to fx. Students, if you, so that's the theory part. I think that's the simplest way I have tried to put in. We will be directly getting in the numerical part so that you can grasp the concept very easily. Yeah. So let's get into the question. If you had difficulty in grasping this, I'll just tell you, slow down this video. Play this video in a slower mode. You can change the mode definitely, or maybe you can go back and watch this again and then maybe come back to the numericals. See, numericals are very simple. So, but you have to be very much strong when you are going for an exam like JEE Advanced. You have to be very strong in all of these basic concepts, and that was the concept part. That's it. So let's quickly get into solving numerical. So the first question that we will take is find the period of the function fx is equal to cos x, y is equal to fx is equal to cos x. So this is the first question. Let's solve this. So students, what I told you at first, what will you have to do? You will have to do what? You will have to put f of x plus t is equal to fx. That's it. That's the first step that you will have to do while finding the period of a function. F of x plus t is equal to fx. So basically this will become cos of x plus t is equal to cos x. Now you will have to solve this. Now students, this is a trigonometric equation, and I hope you all must have done trigonometry in class 11, and possibly you are dealing with this chapter in class 12, or maybe before also if somebody is advanced and trying to do it for physics perspective. They are solving it right now, learning this right now. So let me tell you, so for the students who don't know, let me revise the formulas for you. So this is some additional information I am getting into right now. These are some additional information, trigonometric equations I am writing. So let me just write it over here. So for first one, say for example, cos x is equal to cos theta. If cos x is equal to cos theta, students, the formula of x is equal to 2n pi plus minus theta. X is equal to 2n pi plus minus theta. So this is the solution of x. The solution of equation chapter, you must have dealt with this. Sin x is equal to sin theta, students. If sin x is equal to sin theta, then the value of x is equal to n pi plus minus 1 to the power of n into theta. Minus 1 to the power of n into theta. I am not going into the details of this, how we get it. So we will be dealing with this in solution of trigonometric equation or something of those sort when we deal that. Right now our target is not that. So tan x is equal to tan theta. If the question is tan x is equal to tan theta, the formula is x is equal to n pi plus theta. X is equal to n pi plus theta. So these are the three important formulas that possibly we will be needing today. If not all three, maybe one only, because I will be showing you only one and the rest two are the same. So we will be using this one. Basically, let me erase this part. Now let's erase this part also. So you know what, students, if cos x is equal to, if cos x is equal to cos theta, then the value of x is 2n pi plus minus theta. So basically, if this is your question here, x plus t will be equal to what? 2n pi plus minus theta is x, plus minus x. So this is the solution of this question going by this formula. Yeah, I think till now this is clear to you. 2n pi plus minus x, and where you know n is equal to n, the value of n will be equal to 0, plus minus 1, plus minus 2, blah blah blah, it will go ahead. Yeah, not blah blah blah. So it is 3, 4, 5 and so on and so forth. So let's erase this part and this, let's pull it up only. Let's pull it up. So you get what? Cos x plus t. So the value of x plus t is equal to, the value of x plus t is equal to 2n pi plus minus x, and the value of n is 0, plus minus 1, plus minus 2 and so on and so forth. So this is the value that you are getting. Now since it is plus minus x, so here you have two values of t. So t can either be, so here are two values of t. So if you take the plus x, so this becomes 2n pi, right? If you take the plus x, it becomes 2n pi, and if you take minus x, it becomes 2n pi minus 2x. T becomes, you get two values of t, right? Here you have plus minus. So one is 2n pi, another is 2n pi minus 2x. So now which part will you take? Here, this part. So you are getting t dependent on x, right, students? T is dependent on x. So I told you earlier, if t is dependent on x, that will not give me any solution. That will not give me any solution. Okay. But here you are also getting t independent of x, that is 2n pi. That is what? 2n pi. You are getting that as well. So the positive value of t, independent of x is given by what, students? The positive value of t independent of x is given by what, student? T is equal to 2n pi. T is equal to 2n pi, right? N is equal to what? 1, 2, 3. Positive value. That's why I have removed the negative part and the 0 part. The positive value. So n is 1, 2, 3. And students, what will be the minimum value of n? I told you initially t, the minimum positive value. So n minimum will be 1, and so the t will be 2 pi. T will be 2 pi. The least possible value of t is 2 pi, putting n is equal to what? Putting n is equal to 1, and that becomes the period of the function y is equal to cos x. This is how, students, you will be solving questions on periodic functions. Let me now simply make you understand graphically what periodic function means. Graphically what periodic function means before we move on to solve the next question. So graphically, students, understand that you know the graph of y is equal to cos x. So what is y is equal to cos x? Let me draw the graph. So this is x-axis, y-axis, you know cos x, the value lies in between -1 till 1, -1 till +1, and this is the graph of cos x. This is the graph of cos x. This value is how much? Pi by 2, this value is pi, and so on and so forth. Now students, understand this entire part is how much? This entire part is pi, and this entire part is how much? This entire part is pi, right? So basically what period is, periodic function means you have to find the period. So period means at what interval, by how much interval the function repeats itself. The function repeats itself. So if you see this hump, this part, so this part, entire part is how much? 2 pi, right? Again this part will get repeated. So basically this function, this is a graph like, so something of this sort, this will get, this part, the 2 pi part, get repeated again and again. So that is what periodic function means. So basically this part will not be there, but just for understanding, if you take sin x, I think the understanding will be far better. Let's not take cos x. So y is equal to sin x also, the period will be 2 pi. You need to solve and find it out. But for simplicity, let's not take cos x. Let's take sin x, right? So sin x, the graph is what? Like this, and then it will go on. Similarly, this part will be like this. So basically you see this part, this is pi, right? and this part is pi for sin x. So basically this 2 pi keeps on repeating, 2 pi, 2 pi, similar pattern keeps on repeating. That is the period of the function. Means a similar part at what interval it keeps on repeating. If you draw y is equal to log x, somebody asks you what is the period of y is equal to log x. So if you see y is equal to log x, the graph is something like this. Does it repeat itself? No. This part, is it repeating? No. This part, is it repeating? No. All are different, right? It has a different slope, it has a different slope. So y is equal to log x will be aperiodic or non-periodic. If somebody asks you what is the period of y is equal to fractional part of x. So y is equal to fractional part of x, the graph is how much? The graph is like this, 1, 1, 1. So basically it repeats after every interval 1. This is 1, this is 2, this is 3, 4. So after every interval of 1, this graph will keep on repeating itself. Hence the period. So this is also a periodic function with period of 1. We'll get into the proof of this, but just seeing graphically you can also understand if a function is periodic or a function is aperiodic or non-periodic. So this is the graphical implication. So students, you must have seen that always I have been focused on drawing graph and understanding a problem, what it means. And I request you all to watch my series Play with Graph. Basically, Play with Graph will help you understand everything about graph. Play with Graph will help you not only getting good mark in mathematics, not only understanding calculus, but also Play with Graphs will help you in solving important and the most complex numericals that comes in physics. So basically, calculus part will be the first chapter, that is your mechanics and all. It all involves calculus, and you will be needing that to solve problems. So let's move into the next question. So till now I hope it has been clear to you all. Let's now move into the next question. You will have to find the period of the function y is equal to fx. Y is equal to fx is equal to mod of cos x. Mod of cos x. Students, see, this question is very simple. If I draw graph, I have already taught you, right? I have already taught you what is cos x. The cos x graph, you know, the cos x graph is something like this, right? And if you do mod, so every part of the graph, this is graphical transformation. Already I have seen, I will be linking the graphical transformation video over here. Go and see how to do graphical transformation. Basically the lower part, if you put a mod, the lower part will come up. So basically the graph will now become something like this. So see, after every pi, this graph will keep on what? The graph will keep on repeating. So simply what will be the period of this graph, of this function? This will be pi, simply by seeing the graph and doing some basic transformation. You got it, right? But let's not move it this way. This is my graph method. Let me show you it is the second or the conventional method that we have learned till now, which is what, students? Put you have to find the period of this function. So f of x plus t is equal to fx. That's the method, that's the conventional method to solve periodic function, right? So simply what you will get, mod of cos of x plus t is equal to mod of cos x, right? Simply x is replaced by x plus t, and the second part is like that only. So now what we do is that we square this part. We simply square this part. So if you square this part, square both sides basically. So you will get what? Cos square x plus t is equal to cos square x. What I have done is I have simply squared both sides. So cos square x plus t is equal to cos square x. Now students, you must have seen or known one important formula of cos 2 theta. Cos 2 theta. So I will use this formula. So let me mark it with a different color and I'll erase it out. So cos 2 theta, student, is what? Cos square theta minus sin square theta. Cos square theta minus sin square theta. You know all these formulas, right? I guess you all know these formulas. And you know what sin square theta plus cos square, you also know what sin square theta plus cos square theta is equal to 1. So basically sin square theta is 1 minus cos square theta. Sin square theta is 1 minus cos square theta. So can I write cos square theta minus, so can I write 1 minus cos square theta, students? So basically this becomes 2 cos square theta minus 1. So cos 2 theta, the formula is 2 cos square theta minus 1. So basically 2 cos square theta is cos 2 theta plus 1. So this is one formula, trigonometric formula. 2 cos square theta is cos 2 theta plus 1, right? I will be using this over here. Let's see. So I will be using this over here. So now you have cos square x plus t. Let's put 2 in front of both. Let's multiply 2 in front of both. So 2 cos square theta, right? This is 2 cos square theta. 2 cos square theta, just now we saw. So the formula is 1 plus, can I write this as 1 plus 2 cos x plus t, 1 plus 2 cos x. Can I write this? 1 plus cos 2x plus, just a mistake over here. So this is basically 2 cos square theta, right? 2 cos square theta. So 1 plus cos 2x plus t, 1 plus cos 2x. Can I write this? But just by the same formula that we saw. So 1 plus 2 cos square. This is 2 cos square x plus t is equal to 2 cos square x. We derived the formula just previously, and by that same formula you can write what? 1 plus cos 2x plus t is equal to 1 plus cos 2x. Now you have what, students? You have this 1 and this 1 gets cancelled out. So let's remove this part. These 1 gets, so this cos is equal to this cos. Just few minutes back in the previous example we saw the solution of this. So 2x plus t is equal to 2n pi plus minus 2x, plus minus 2x. Simple. So 1 is 2x and 2x gets cancelled out, and that will be the period. So that is what? T is equal to n pi. T is equal to n pi. The only part that you are getting independent of x, another one will be dependent on x. You can solve x, that will give you t is equal to n pi minus 2x. Let's remove that part. So t is equal to n pi. The smallest value of n will be 1. We will not take 0 or the negative part. And then you get the period of t, the period of this function. For n is equal to 1, you get the period as pi. So the period of the function y is equal to fx is equal to mod cos x is pi. Very simple, students. We saw it graphically also, and by the conventional method, putting f is equal to x plus t is equal to fx, we have seen how to solve this numerical. Let's get into the third numerical, students. Let's get into the third numerical. So basically by solving numericals, we are seeing the different concepts. Yeah, different concepts. So basically the third question is y is equal to fx is equal to cos root x. Cos root x. You will have to find the period of this function. So again, put f of x plus t is equal to fx. The same conventional method. F of x plus t is equal to fx. So cos of root x plus t is equal to cos of root x. Cos of root x. Solving this, what you will get? X plus t root is equal to 2n pi plus minus root x. This is the solution that you are getting till now. Root x plus t is equal to 2n pi plus minus root x. Students, understand here, from here t is equal to what you get? 2n pi plus minus root x whole square. So basically I am squaring both sides and I am taking x this side. So t is equal to this part. So you are getting t is equal to 2n pi plus minus root x whole square minus x. Students, here you can see clearly that t is always dependent on x. T is always dependent on x. You will not get t independent of x in this question. Therefore, fx is not periodic, non-periodic or aperiodic function. Cos of root x is a aperiodic function. This was a very simple question. We have seen two questions that were periodic. Same you can do for sine also, students. I am not showing for sine. Sine also I had shown graphically about sine. Right? Let us move to the fourth question, students. Let us move to the fourth question. So basically we are still in the part wherein we are using the fundamental principle how to solve the question. The fourth question we have already seen it graphically, but let us see. Find the period of the function fx is equal to x minus box x. So this is the greatest integer function, students. Already greatest integer function. We have already seen it in earlier videos, in earlier functions videos. Do watch those videos, students. I will be linking the playlist of entire functions. Do watch that. If you are enjoying my video, students, do subscribe to my channel. That will give me encouragement in making more such videos, delivering more videos to you all. Yeah. So students, let us now understand this question. Again, let us take the conventional method. Let us take the conventional method, which is f of x plus t is equal to fx. F of x plus t is equal to fx to solve this question. If I take this, what will I get? X plus t minus box of x plus t is equal to fx. So x minus box x. Clear till here? X plus t is equal to this, right, students? Till here, is it clear to you all? X plus t minus box of x plus t is equal to x minus box of x. Now this x and this x will get cancelled. Basically, you have t is equal to box of x plus t minus box of x. Till here, is it clear to you all? So simple equation, box of t is equal to box of x plus t minus box x. Now let me teach you very simple thing. Let's see, only looking at the numerical you can get the answer. Students, this is box. So you already know greatest integer function transforms any number. Say for example 1.67, box of 1 plus 67 is 1. Box of 2.32 is what? 2. So basically applying the nearest, the integer. So basically if this is 1 and 2, if you get any number, boxing this will give you the previous integral value. So greatest integer function will give you the previous integral value. So basically x plus t minus box x. So this is also an integer, student. This is also an integer. This is also an integer, right? Integer minus integer is what, students? Integer minus integer is also an integer, correct? T is an integer, right? T is an integer. So understand, integer minus integer is also an integer. And students, what is the least possible integer? Least possible integer. Least possible integer is what, student? Least possible integer is 1, right? The least possible integer is 1. Hence, the period of this function that is given is 1. The period of this function is 1. The period of this function is 1. Also, students, do understand that x minus, so you know this thing, right? X is equal to this plus this. We have solved numericals also on this. So x minus this is basically fractional part of x only. Yeah, fractional part of x only. And we have seen the graph of fractional part of x and solved graphically also. We have seen that the period was 1. It was repeating. This part was repeating. So basically if I draw over here also, this part keeps on repeating, right? This is the fractional part of x. After every interval of 1, this part keeps on repeating. Hence the period for this function is 1. Yeah. So let's move on to the next problem. Students, let me show you the characteristics of 3 important functions over here. We saw the function x minus box x, right? Y is equal to x minus box x, or you can say fx is equal to x minus fx is equal to y is equal to x minus box x. So this is one. The another one is root of x minus box x, and the next one is x minus box x whole square. So 3 functions, students, I have taken over here. Y is equal to x minus box x, square root of that, another is the square of that. So basically I will draw the graph also and show you what these mean, but understand these 3 have a, so basically this is fractional part of x. So square root of fractional part of x and squaring of fractional part of x. Yeah, this is it. So these are functions with period. So you can note it down. These are functions with period of 1. All 3 are functions. These 3 have, we already saw this one. You can, if you want, you can solve it on your own. The period of these functions, you will be getting this as 1. Also the range of these functions, is from 0 till 1. 1 is not achievable. 1 is not achievable. So basically what we are saying is that the value of fx is lying in between what? 1, which is not achievable, and 0, which is achievable. So basically this is the period, this is the range of the function. When you speak about the range, so this is the range. This is the period. the third part. The third important characteristics is that this function is discontinuous. This function is, all three functions are discontinuous. We have not yet gone to discontinuity, but I'll explain. It's very simple. Discontinuous at all integer points, at all integers, at all integers. So basically, if you see the graph of y is equal to this one only, say I am showing this. So this part is 1, 1, 2, 3. This is the fractional part of x graph. So if you see this graph, the period is 1, right? So every 1 it keeps on repeating. The range, that is the value of y. So you can see from 0 to 0. So basically at the all integral points you are attaining a value of 0, right? No, any integer part, the fractional part will be 0. That is the meaning. So here already we have seen it in graphs. So now the range of this function is 0. 1 is not achievable. You can see the dot over here. This part is not there, not included, right? And it is discontinuous at all integers. See, what is a discontinuous function? Say for example, this is a graph. So this is a continuous graph. If there is a break in the graph, at that point this becomes discontinuous. So you can see the graph was going like this. If it would have continued like this, it would have been continuous, but it gets discontinued. The graph again starts from here. Again it gets discontinuous. So basically at odd integer points, the graph becomes discontinuous. This is the meaning of the third line, the third important characteristics of all the three functions. So basically you have to keep this in mind from exam point of view. Students, basically what happens is state joint entrance that you give. Say for example, somebody is giving West Bengal joint entrance, or maybe some other Bihar entrance, or so MP entrance, whatever, the state level entrance examination. There these kind of question comes directly. What is the period of this function? It will be a direct question. What will be the range of this function? So you need not think there, keep on solving, put fx plus t is equal to fx and solve the problem. Simply you need to keep some questions in your mind, keep them as a formula that okay, let me use this as a formula and then move ahead and solve critical problems. So I think these 3 points are very important. I'll also show you the graph of the three functions, also the graph of the three functions basically. So let me take this point. I'm not going into details since all the graph questions you will get in my videos of play with graph. So basically this is the graph of, let me draw first, then I will explain it to you. Let me draw first. So basically this is 1, this is 0, this is 1, 2, 3, right? So this is the graph of which one? This is the graph of y is equal to x minus this. So this is the graph of this one. Y is fractional part of x. The black one that you are seeing is the graph of y is equal to x minus box x, or x is equal to, or y is equal to what? Fractional part of x, right? This is the graph of that one. Now, if I draw graph like this, if I draw again the same thing, it is 1 here and it is lagging. If I draw the graph like this and so on and so forth. So this red line that you are seeing, is the graph of this one. Y is equal to square root of fractional part of x. So basically instead of straight line, this line will become like this. So it is nothing but something of this sort. Square root, what happens? This happens. So you need to solve it and think on your own why I am drawing this graph like this. But now for the time being, you have to keep this in mind. Similarly, if you square this part, it will give you like this. It will give you like this. It will give you like this. So basically, the lower part is the graph of y is equal to fractional part of x whole square, or x minus box x whole square. Right? Clear? The middle, the straight line is for y is equal to x minus box x. The upper part, the upper envelope is y is equal to square root of x minus box x, and the lower part is for y is equal to x minus box x whole square. I think this is very important and you all have to keep this in mind and solve numericals. So I have already taught you this. Let's move on. Let's move on to the fundamental theorems or principles of periodic function. You need to note everything down. Maybe I will not write it down, but I will speak out. Yeah. So the first important. So basically we are dealing with, let me write it down. Important results. You have to memorize this. Very simply, let me tell you, you have to memorize this, or you have to keep this in mind. You know the concepts, so that's why I'm saying memorize this. You will never memorize mathematics again, I am saying. So understand, for functions sine to the power of nx, right? This is sine to the power of nx, cos to the power of nx, sec to the power of nx, and cosec to the power of nx. To the power of nx, these all are periodic functions with period pi when n is even. So basically, if n is even, so the period will be pi. If n is even, which means sine square x, cos to the power of 4x, sec to the power of 6x, cos to the power of 8x. If n is even, the period of all these functions will be pi. Yeah. And if n is odd, the function will be 2 pi. We already saw cos to the power of 1x or cos x, the period was 2 pi. Is it clear? So if n is, so even, odd, if n is fraction, it will be what, students? We saw just now, it will be 2 pi. If n is fraction, so basically you have to understand, when n is odd or fraction, when n is even, pi will be the period. When n is, and it will be 2 pi, the period will be 2 pi when n is odd or fraction. When n is odd or fraction, the period will be 2 pi, right? So for example, if I tell you, so let me mark with a different color, sine square x, students, what is n? It is what? What is n? What is n, students? This is how much? This n is odd or even? The n is even, right? So it will be how much? It will be 2 pi. Period of sine square x is pi or 2 pi? N is even, so this will be pi, correct. So n is even. For even you will get pi, for odd and fraction. So basically, if you have sine to the power of 3x or root sine x, then it will be how much? It will be 2 pi, right? Root sine x, it will be 2 pi, and for even it will be pi. This was a simple result for this. So let me erase this example out. First point was clear to you all. Next, move on to the next question, next important point. So write it down. For tan to the power of nx, and cot to the power of nx. These two are different. For tan to the power of nx, so the period is pi. The period is always pi, irrespective of n. The period is always pi, be it odd, even, be it fraction, the period will always be pi. So this was for tan, sine, cos, tan, everything is done, right? For mod, cos, mod sin x, mod cos x, mod tan x, mod cot x, mod, every mod, sin, tan, cot, all included here. So there is no separate differentiation between these. So sine, be it cos, be it sec, cosec, tan, cot. Let me also write tan, else you will not get confused, and so on. All the parts here, irrespective, everything, the period will be pi. The period will be pi if you apply a mod in front. I think this is clear. This is the third point. Now coming to the fourth point, students. The fourth point is very important and you have to keep this in mind. Say if fx is a periodic function with period t. Say fx is a function with period t. Right, students? If fx is function with period t, k of fx will have a period t only. It won't impact t, right? Because t is dependent on x. No, yeah, t is dependent on x. Simply, if you would have seen a transformation of graph, this formula wouldn't have needed much explanation for those who have already seen my video, right? F of x plus b, so let me just erase the other results over here and let me pull this up a bit for you all to understand and focus, because this is very important. This will be frequently used. So you saw fx, so this is the main function. Let me tell you, the main function is fx, yeah, it has a period of t. This is given. fx you know the period is t. Say for example, you know the period of sin x is 2 pi. Something of that sort. So fx is t, you already know. So k of fx basically. So basically 2 sin x. It will have what the period will be? T only. Means 2 sin x will have a period of 2 pi only. It won't impact. So this is first thing. Second is f of x plus b. This will also have a period of t. Yeah, similar because it will be shifting only. So yeah, this is very simple, very clear always. Yeah, f of x plus b will always have a period of c. The third is f of x plus c or minus c, whatever. This will also have a period of t, students. This will also have a period of t, right? Fourth one, f of ax. F of ax. Now the game comes here because x is impacted. So the period will be t of mod a. T of mod a, the positive part of a. If it is sine of minus 5x, so 2 pi by minus 5. And minus 5 becomes 5, so 2 pi by 5. That will become the period. Correct? I think this is very clear to you all. T by mod a. So basically, if you have been given and asked k of f of ax plus b, k of f of ax plus b is a function with period how much? Is periodic with period of t by mod a. K and b are not impacting. Thus, you have to mark that the period is affected only by the coefficient of x. You write it down. Period is only impacted by the coefficient of x and by no other factor. And by no other factor. This was the fourth important result that I told you. This was the fourth important and the most important result that I told you. So I'll give you an example also over here. Let's deal with see an example also over here. Say for example, you have a question that is, you have to find the period of 3 sine, let me take 2x plus, so fx, let me write it fx. So you have to find plus pi by 9 and plus at front is 5. You have to find the period of this function. Big problem, very simple. 3 won't impact. Pi by 9 won't impact. This 5 won't impact the question. Only the coefficient. Sin x, you know the period is how much, students? 2x, 2 pi. And here it is 2. So it will be divided by mod of 2. Positive part, so pi. So this function will have a period of pi. Very simple, very simply put. This is a very important question also. Sometimes asked in state level or JEE main entrance examinations, and this is how you need to solve it. Now coming to the fifth important result. So this was the fourth result which was very important. Coming to the fifth important result, students. The fifth important results. Say for example, you have a function hx. You have a function hx defined by a of fx plus minus b of gx. A of fx plus minus b of gx. A and b are constant numbers, yeah, right? So you can understand by that. So basically, if fx and gx are periodic function with period, say for example, fx is periodic and it has a period of t1, gx is also periodic and it has a function and it has a period of t2. Basically, hx is also a function which is formed by two functions, fx and gx. Fx is given; these are all given, which I am saying. Fx is periodic with a period of t1, and gx has a period of what, students? It has t2. So now hx is also a periodic function. You have to know that this is periodic with t1 and this is periodic with t2. Then hx is, this is not given. This is now the conclusion. Hx is inference from that. This was given. Hx was a function of fx and gx, and t1 was the period of fx and t2 was the period of gx. Then inference is hx is also periodic. Hx is also periodic. And what is the period of hx? The period of hx will be LCM of t1 and t2. The LCM of hx is periodic, and the basically the period of hx will be the LCM of t1 and t2. This is the fifth result and very important result. Also now, students, you have to keep one more thing in mind, that this result is not always applicable. So this you have to keep in mind. Why this is not applicable, if time permits, we'll take it in this video, and maybe I'll show you one example also why always it is not applicable. Many tutors don't say this, and often students go and mess it up in the examinations. So I will just tell you that to keep this in mind, this result is not always applicable. Why is it not applicable? I'll try to show you one problem. So now student, let's get to solving one numerical over here. Find the period of the function. So let's remove important results also. We have seen 5 important results. The question is, you have to find the period of function fx is equal to sine of 2 pi x plus pi by 4. This pi by 4 is worthless, you can understand from here itself, yeah, plus 2 sine 3 pi x plus pi by 3. So you will have to find the period of the function sine 2 pi x plus pi by 4 plus 2 sine 3 pi x plus pi by 3. Students, if you want to solve this numerical, you can pause this video and solve it on your own there, and then you can watch the solution of this video. Now understand students, here this is a periodic function because this is sine x, and what is the period t1? What is the period of this function, students? Basically this is fx is some gx plus hx or whatever you can say. So t1, the period is how much? 2 pi upon 2, right? So the period is how much? The students, the period is pi over here. Very sorry students, very sorry. The general, what it is, what is the period of sine? It's 2 pi. So 2 pi, and what is in front? In front you have 2 pi. So basically the period of this function is 1. The period of this function is 1. And this function, students, t2, what will the period? 2 pi is the general period divided by 3 pi. So basically 2 by 3 is the period of this part of the function. Now what will be the function of, what will be the period of fx? The period of fx, so period, I am writing like this, period of fx will be LCM of 1 and 2 by 3. Now many will mess up with this, so let me also teach you how to find the LCM of fractional numbers. Say for students, understand students, this is some, I am diverting from this topic. So now if you are asked to find the LCM of 3 numbers, fractional numbers, say for example 5 by 8, 3 by 4 and 1 by 2. You have to find the LCM. The question is find the LCM. I am digressing from that just to show you one concept. If you remember or not, you must have learned in earlier classes. So LCM of this number will be, fractional part is LCM of numerator by HCF of denominator. So what is HCF? HCF is the highest common factor. Right? LCM of numerator, what is the LCM of numerator? 5, 3, 1. So 15 is the LCM of this. And what is the highest common factor? So basically 8, you can write it as 1 into 2 into 4. So whatever. So highest common factor. So this is 2, right students? This is the common. 2 can be written as 1 into 2. 4 can be written as 1 into 2 and so on and so forth. So the common factor is what? Similar common factor, the highest factor that will divide all the 3 will be 2, right? 2 will divide 2, 4, 1 is also a factor, but 1 is not the highest, 1 is the least. 2, yeah, 2, 4, no, 4 cannot divide 2. So basically 2. So 15 by 2 is the LCM of this number. You got it right? So this is how you find. Now this is simpler. Just LCM of numerator by HCF of denominator is what is used to find the LCM of fractional numbers. So here also you have 1, you have 2. So basically to find this, what you will do, 1 and 2, what is the LCM of 1 and 2 on the top? It is 2. And denominator 1 and 3. What is the highest common factor? 1 by 1, right? So 1 is divided by 1 only, so 1 will be the factor. So basically the period of fx will be equal to how much? The period of fx will be equal to 2. I think students, this question was very clear to you all. I also taught you how to find the LCM of the fractional part, and you got it over here. Yeah, students, so basically understand that sine x, the fx is equal to sine x, the period is 2 pi. If sine of 2 pi x was given, basically this part, so that's why I did 2 pi by 2 pi. So this will be 1, right? So this number, the n was How much? That was 2 pi. That's why it reduced to pi. Very simple. I am pretty sure that I take very basics to solve a question. Now students, understand, I told you, right, that formula is not applicable everywhere. So I'll tell you why. Find the period of fx is equal to cos square x plus sin square x. If the question is find the period of the function fx is equal to cos square x plus sin square x, students. Now understand students, we have already dealt with this question. What will be the period of cos square x? The period of cos square x will be pi, right? We already saw it in the previous principles that we learned. What will be the period of sin square x? It will be pi. Clear, students? Remember which formula, which theorem was that? The first theorem, sin to the power of nx, cos to the power of nx. Yeah, we have learned that if n is odd or fraction, the period is 2 pi. But if n is even, the period is, if n is even, that is 2, the period is pi. Yeah, I think this is very clear to you all till now. So now the period of this function is what? Pi. The period of this function is pi. So period of fx will be LCM of pi and pi, which will give you how much? Pi. The LCM of pi and pi is what? Pi. But students, understand, this is not correct. This is not correct. Pi is not the period of this function. Students, what is cos square x plus sin square x? Cos square x plus sin square x is equal to 1. It is a constant number, and a constant number wouldn't be periodic. So basically this function is nothing but y is equal to fx is equal to 1. So this is the function, y is equal to 1. This is the function. This is the graph of this function, y is equal to 1. What period will it have? It won't have any period, and hence you see it's a constant function. Basically this is a constant function. Y is equal to what? Constant function, and hence it will have no fundamental period. No fundamental period will be available for this. Hence you see this was a failure case. So you have to keep these things in mind. You can also think of some other problems. Maybe in this video I am not covering. You can check this. Fx is equal to mod cos x plus mod sin x. Do solve it on your own and think why this will also fall something in this case. Basically, yeah, its actual period is how much and why and all. So you need to think on this question, that I am leaving this to you all to solve it on your own. Students, I think this is pretty much the video about the periodic functions, how to find period. If maybe I get time in the next video, we can see into some of the numericals of periodic functions, or maybe separately out of this series that I'm making on calculus and function. Out of this series, we will be taking some questions of periodic functions. Already we have taken many questions in this video. We will be taking out some questions, some important questions that have come in JEE mains and advanced. And also you need to comment what all numericals you want me to cover, and I'll definitely go into that. Students, if you like this video, do subscribe to my channel, do share it in your circle. Till then students, goodbye, take care.